Hi, and welcome to the video on types of chemical reactions. Today we're going to look at how to recognize the 5 different types of chemical reactions based on their chemical equations, and then look at how to balance each of these chemical equations. So let's begin with synthesis. Synthesis reactions, you can see here, are pretty straightforward. They are 2 or more reactants, A plus B, but they always combine to form one product. Magnesium and nitrogen combine to form magnesium nitride. If you look at the picture, 2 reactants come together. So the key is only ever look for one product for these types of reactions. So let's try and balance these. I always do the oxygens and hydrogens last. So if we look at the nitrogens on the reactant side, there are 2. So I'm going to put a 2 here, and there is only 1. So immediately on the product side. So immediately I'm going to put a 2 here, and that balances those. Now we can look to the oxygens and hydrogens. There are 2 hydrogens on the product side, and there are 2 on the reactant side. So those are balanced. And if we did everything right, for the last element remaining, it should be balanced. There are 6 oxygens on the product side, and be careful, there are 5 here, plus 1 is 6. That reaction is balanced. On the other one, we have oxygen and hydrogen, and then we have the element lithium. So there are 2 of the La on the reactant side and only 1 on the product side. So I'm going to simply put a 2 coefficient there. And then I can start counting my atoms, 2 and 2. As for the oxygens, actually let's do let's do the oxygens. There are 2 times 3 is 6 on the product side. There are 3 and 4 on the reactant side, but we need 6. So we have 3 over here, and I'm not going to mess with that because there's another compound here that we've balanced, or an element that we've already balanced. So I'm going to add to the water molecule. If I add 3 more oxygens, that gives us 6. And then if you simply count the hydrogens, we have 6 on one side and 6 on the other, balanced. That's the synthesis. Now let's look at the opposite of that, decomposition. Decomposition is merely taking one reactant and decomposing it into its different compounds. So hydrogen peroxide gets decomposed into water and oxygen. One reactant, 2 or more products. So let's look at balancing these decomposition equations. The first one, let's look at oxygen last. So we look at the potassiums and nitrogens first, and actually they're balanced. There's 1 of each on both sides. So the oxygens are the ones that are really causing the trouble. There are 3 on the reactant side, but there are 4 on the product side. So I'm going to start by adding a 2 over here. We're going to try it and see if it works. So that impacts our potassiums. It impacts our nitrogens. And then we need to then balance those on the product side. So I'm going to do the same thing over here, and they're still balanced. Now let's count our oxygens. There are 6 on the reactant side, and there are 4, 5, 6 on the product side. Balanced. Go ahead and pause the video here so that you can try your hand at this decomposition reaction. All right, and let's see how you did. You should have the coefficient of 2, 2, and 3. Atom counts, there should be 2 sodiums and 6 nitrogens on both sides of the chemical equation. After decomposition, we'll look at combustion. Combustion is what you know as a fire. There's some fuel source combined with oxygen yields the same products every time. Carbon dioxide and water, and lots of heat is released. So that fuel source is always some combination of carbon and hydrogen. That's key to note. And then the other components of this chemical equation don't change ever. Carbon dioxide, water. So the fuel source is some sort of carbon. I'm just going to put in a certain amount of hydrogens, and oxygen is a reactant, and then the products are CO2, water, and heat every single time. These reactions are tougher to balance. I always start with the carbons, and in this one there are the carbons are balanced. So we need to look at the hydrogens and oxygens. So to do that, I'm going to start with the H's. There's 4 on the reactant side, so I'm going to make there be 4 on the product side by simply adding a 2 coefficient. Now the oxygens. There are 2 plus 2 is 4 oxygens. And so there's only 2 on the reactant side, so if I add a coefficient of 2, that gives us 4 oxygens. And by adding those coefficients, we did not change the amount of carbons because there's no coefficients needed in front of them. So this is balanced. You can go ahead and pause the video here and try your hand at this combustion reaction. Now these are tougher, so if you got the right answer, you should have a 5 coefficient, a 3 coefficient in front of the carbon dioxide, and a 4 in front of the water. The atom counts for both sides should be 3, 8, and 10. Now on to the last 2 types of chemical reactions, the replacement reactions. Let's start with single. I like to look at the letter representation for this and the name of the type of reaction, a single replacement. So this single element is going to replace another element in the compound. It's going to kick one out, and it's going to leave that element out in the cold. A single element replaces another element. So if you look at this analogy, dancer A wants to dance with dancer C, so he kicks out B. Single replacement. So let's try and balance. Let's start with potassiums. There's 1. And there's 1 on the product side. Perfect. Let's move to the next element. There's only 1 Cl, 1 chlorine on the reactant side, but 2 on the product side. So let's put a 2 out in front of the potassium chloride. However, by putting that 2 there, that influences the amount of potassium. So I'm going to put a 2 on the reactant side. Now that then leaves our potassiums unbalanced. So I'll put a 2 in front of the potassium fluoride on the product side to make those balanced again. If we've done our math correctly, the last element should already be balanced, and there are 2 fluorine atoms on the products and 2 on the reactants. Balanced. Go ahead and pause here to try your hand at the other single replacement reaction. And if you balance this one correctly, there should be a 2 in front of the hydrogen chloride, and that should be it. Our atom counts should be 1, 2, 2, 1, 2, 2. A single magnesium kicks out one other element in the compound, kicks out hydrogen, and there's our new compound, magnesium chloride. Single replacement. The last one is very similar to single replacement, but we're doing 2 replacements, double. So take a look at the dancing analogy. You have 2 couples dancing, A and B and C and D. And simply both partners swap with each other. 2 compounds on the reactant side and 2 compounds on the product side, and they switch partners. So these are probably the biggest, the beefiest looking reactions because we're dealing with multiple compounds. So let's try our hand at this one. Notice we have some polyatomics here. And if they're on the reactant side and the product side, we can treat them as 1. So let's begin. I'm going to start with Ag with silver. There's 1 silver on the reactant side and 2 on the product side. So let's balance those by adding a 2 coefficient for the reactants, 2 and 2. That means there are now 2 nitrate groups. So I'm going to go ahead on the product side and add a 2 in front of the other nitrate to balance those. And then finally, the potassiums and the sulfates. Let's count those. There are 2 potassiums on the reactant side and 2 on the product side. And so what's left are the sulfates. There's 1 sulfate group and 1 sulfate group. So this is balanced. So I always, if these polyatomics are on both sides, it's much easier for counting's sake if you keep them grouped as one polyatomic, rather than look at all the nitrogens and all the oxygens separate. So try your hand at this double replacement reaction and then come on back and I'll give you the answers. All right, our answers here, we have 2 coefficient, and that should be, oops, sorry, and then 2 here. So our reactant and product atom count should be 1, 2, 2, 4, 1, 2, 2, 4. So this is double replacement. We're taking magnesium was dancing with hydroxide, and then it switched partners to dance with chlorine. So these two guys came together, and then these came together as well. So that's a double replacement reaction. Those are all the types of chemical equations and how to recognize them and how to balance them.